All right, in this lesson, we'll be able to find the sine, cosine, tangent, secant, cosecant, and cotangent of any angle that goes around the circle in any direction, whether it's positive or negative. The first one here is 210 degrees. So we make our XY axis 210 degrees means that I'm turning 180 and then 30 extra. So 30 degrees is right here. That's my reference angle. My actual angle, right? My actual angle is 210 degrees, but I refer it back to 30. So we always remember this is 0, and we turn ourselves around 210 degrees. If I went this way, it'd be negative, but I'm going this way around, so 210 degrees. So 30 is my reference angle. This would be 60, and this is 90. So I'm in the third quadrant. You never, ever, ever draw your triangle over to the y-axis. You always go back to the x-axis. Then we tell the story of the car and the helicopter. That's supposed to be green. Doesn't look very green, does it? I'll make it, there we go. Now it looks green. My stopping point is out here. So you can go by road and you can drive, make a left-hand turn and go, right? You can drive this way and this way. Or if you're in a helicopter, you would turn your helicopter around and then you'd fly this direction. So I guess I always like Yoshi, right? So he's going to drive this way, which is a negative direction. So he's driving west. So we describe that in a negative direction. And then he's going south. We also describe that in a negative direction. So it's boom and boom. So what are those two negative directions? The side opposite the 60 degrees is always the square root of 3. But since we're going to the west, right, it's negative. And then we're going to the south. The side opposite of the 30 is 1, but since it's south, we call it negative 1. All right, so we go negative square root of 3, make a left-hand turn, and we go negative 1, and we get from that dot to that dot. Then, if we're in a helicopter, or we add our flying apparatus to our Yoshi here, now he can fly. Look at that. Whee! So he's going to turn 210 degrees, right? And then he's going to go out a distance. All right, so this would be a distance of, side opposite of the 90 is 2. Distance is always positive, so the hypotenuse is always positive. Once you have this drawn, then you're basically done because you just follow the y over r, x over r, y over x. So sine of 210 degrees is y over r, so it'd be negative 1/2. Cosine of 210 degrees is negative square root of 3 over 2. Tangent is the slope ratio. So you can see it's actually a positive slope, and it makes sense because when you put a negative over a negative, you're going to get positive. So it's 1 over radical 3. Then the other ones are all the flippy upside downs. So we got cosecant of 210 degrees would be negative 2. The secant of 210 degrees would be 2 over radical 3, but it's negative. I always put the negative on the top of my fraction. And then this one here, cotangent of 210 degrees is equal to the square root of 3. So starting point, stopping point, negative, negative. I'm in the third quadrant. Positive distance always, reference angle of 30, the actual angle is 210 degrees. And very important, you always make the triangle, to complete the triangle, you always go up or down to the x-axis, never to the y. Bad, bad. All right, the next one is 8 pi over 3. So I wrote it out in words because it's easier to type it that way on the Smart Notebook slide. So it's 8, I'm going to write in blue, 8 pi over 3, which would be 2 and 2/3, right? 2 and 2/3 pi. So it's 2 pi plus 2/3 pi. We know that that's one trip around the circle, and you can make infinitely many trips around the circle. So one trip around the circle would be 2 pi, 2 trips around the circle would be 4 pi, 6 pi, 8 pi, and then you can start going backwards, you know, -2, -4, -6, -8, right? So you can keep going around the circle many, many, many times because it's a circle, there's no end to it. So this is one trip around the circle and then 2 pi over 3. So I really just need to know what 2 pi over 3 is. Well, 2 pi over 3, you can do the conversion, or you can remember that pi over 3 is equal to 60. So 2 pi over 3 would be 120. So my actual angle is 8 pi over 3, but I'm really just going to go 90, 30 past. So here's my angle right there. So I'm gone 30 past, which means this has to be a 60-degree angle there, and you drop it down. So I went all the way around, and then I went 120 more, right? So it's a 60-degree angle there. So my reference angle is 60. That means this is 2. This would be 30 up here, so this is 1, and this is radical 3. But you have to think about the car thing again and the helicopter thing. So this would be green and red. So if I'm going to get to the second quadrant, I have to go in the negative direction. So this would be -1. So I go -1 and then up square root of 3, distance of 2. There it is. So for time purposes, I'm just going to do sine, cosine, and tangent. So sine of theta, cosine of theta, tangent of theta. And this is theta, so I can save time by doing that. And then sine would be square root of 3 over 2. Cosine is -1 over 2. And the tangent would be negative square root of 3 over 1, which is negative square root of 3. Flip them over and you get the other ones. Okay, find the sine and tangent of theta when cosine of theta is 2/5 and theta is in the 4th quadrant. All right, so I'm in the 4th quadrant. So I need to make my triangle in the 4th quadrant. So it says cosine of theta is 3/5. Again, I typed this out, so that means it's easier to write. So then we have the x over the r. So the x direction is 3 and r, but it's in the 4th quadrant. So the 4th quadrant's over here. So I go 1, 2, 3, and then the radius is 5. So something like this. This would be positive 3. This is a positive radius. And then I just need this 4th side here. Well, hopefully you recognize by now this is a 3, 4, 5 triangle. So this is 4. So the Pythagorean theorem, 3 squared plus 4 squared is 5 squared. But we still have to remember the car airplane thing. There's my stopping point. Here's my starting point, right? So if I'm going to go to the 4th quadrant, what do I have to do? I have to hop in my car and go 3, and then I go down or south, which would be negative. And then there it is. So here's my, the angle is actually probably this. The reference angle is in there. And we're supposed to find the sine and tangent. So now we're ready. Sine of theta. Sine of theta is y over r, so it's negative 4/5, and tangent of theta is slope, and it's going down, right? So it's a negative slope, y, which would be negative 4 over x thirds. So there's the answer to that one. So here's the homework, page 551, and it's all odd numbers. And then this is all, you know, basically the stuff And then when you get to 83, it's kind of like the last example we did. So we're in the second quadrant. So on 83, you're in the second quadrant. So it means you're over here. So the y value is 12 and r is 13. So y is 12. So that means it's really steep. And by the Pythagorean theorem, right, this would be 5. 5 squared plus 12 squared is 13 squared. It's a 5, 12, 13 triangle. So this would be, right, so our reference angle's there. There's our actual angle. And we have to remember our green dot, red dot. All right, so if I'm going to go on the streets, I'm going west, young man, west. West is negative, so that means this has to be a negative 5. And then you turn and you go north, that's positive. So it's a negative here, a positive there. And then you just have to, I believe the directions are, you'll have to look at the directions again in the book, but it's just basically just finding the angles. So you got cosine would be x over r. You got tangent sitting right there. Once you draw this, you're pretty much done. So drawing is very important. Here's a secant one. So in 93, it's a secant one. So secant would be cosine flipped upside down. So cosine is 1/2. All right, cosine's 1/2. Now, and then it says sine is negative. Sine is negative, but cosine's positive. All right, so here I'm going to teach you the all students take calculus, which, by the way, you should. All students take calculus. All the trig functions are positive in the first quadrant. So this helps you to know where to draw them. Sine is positive in the second quadrant. Cosine is positive in the fourth quadrant, and tangent is positive in the third quadrant. So I can know where to draw this because it says cosine's positive. The cosine's positive, it's 1/2, so that means it's here and here. Sine is negative. Well, sine is positive here, so it has to be drawn in the fourth quadrant because sine is negative. So I'm drawing in this fourth quadrant. This is x over r, which makes sense. It's down here and here. X is 1, r is 2. It's a 1, 2, oh, radical 3. 1, 2, radical 3 business. And again, we got our colors in here. Start, stop, positive. Ooh, this way's negative, so make it negative. And once you have this drawn, you can do sine, cosine, and tangent of all that stuff. All right, peace.